So, after half an hour, I suddenly got the idea that seems to solve the problem. And we don't need all this. The idea was that in a field, we have polynomial division. Hence, we can factor when we know a root. So, if we have a polynomial so that alpha is a root, then we can factor out x minus alpha to get some quotient and no remainder. That means that a polynomial of degree n can have at most n roots. And in other words, if f of x equals 0, where f is a polynomial, has infinitely many solutions, then f vanishes in the sense that all coefficients vanish. Now, if we go back to this equation, if it holds for an infinite number of, if it's an infinite field, then it holds for an infinite number of solutions. And that means that if we subtract that is a polynomial, and it vanishes for an infinite number of elements of the field, thus the coefficient to all the terms vanish. Therefore, they must be equal, and that means that alpha plus beta plus gamma equals n. So that's it. Now, if we go back to the field with two elements, then we can construct a polynomial x minus 0 times x minus 1 and I claim that p of lambda x equals lambda squared times p of x for lambda equals 0 and unity. In any field, finite field, we can construct a polynomial this way. And then we should be able to construct a counterexample in any finite field. All right, so I wasn't able to get this idea online, so I worked along some lines I've recently seen in field theory, which didn't work. It took half an hour to get the idea. Well, problem solved.